So if you're having trouble with any of these problems related to average, I encourage you to go back to that very first packet we had with the cups and noodles, because that started very basic and then built up. So for example, if we had 5 cups and you knew the average number of noodles in the cups was 7, but you didn't know how many noodles were in each cup, okay? It's possible then that every single cup has 7, okay? However, if, if not every cup had 7, maybe this one had 2 less, but then this one would have to have 2 more to compensate, and so on, okay? So again, maybe this only had 1, that's 6 less, and so then this had 13, which is 6 more. Okay, but however the noodles were distributed, we knew if there was an average of 7 in 5 cups, we knew that there had to be 7 times 5 total noodles. Okay, we don't know how it's distributed, but we knew that the total number of noodles in those cups had to be 35. So in number 3, if we have a class average of 85, sometimes students will tell me, well, we can't do this problem. We don't know the individual scores of these 26 students. But what we do know is that if students were cups, okay, so we would have 26 cups. Obviously, I'm not going to draw them all, but if I had 26 cups, I don't know the individual scores, but I know that if we evened out their scores, each cup would have to have 85. Okay, and then finally we get this last cup, right? Our 27th student. Okay, and our 27th student, in his cup or her cup, we only have 22 points. Okay, so amongst these 26 cups, even though the 85 is not, I'm sure not, although it's possible, I'm sure not every single student got an 85. However, if we were to find the total number of points in those 26 cups, the total number of points would be this. Okay, and then they're just distributed, maybe differently, maybe this student got an 80, but that student got a 90, and so on. But that doesn't affect, giving 5 to one cup and taking 5 away from another cup. That doesn't affect the total number of noodles in the cup. Or actually, no, we don't have noodles this time, we have points. Okay, so our cups are students and our noodles are points. So the total number of points scored by these 26 students is 2,210. And then we have to add in the points then scored by this last poor person who only got a 22. And therefore, the total number of points scored in the class, if we add those two together, is this. And then when we divide, there were 27 total students in the class that got that many points when we combine all their points. And therefore, the new class average is an 82.6 repeating. Okay, so this would be known as an outlier. Although he or she didn't bring the average down too much. Part of that is because it was a relatively large data set. Okay, in a very small class with only like 14, 15 students, one low score would bring the average down more. But this was a relatively large class, so this student, although their score was an outlier, didn't affect the class average terribly, the way that sometimes outliers can really skew our averages, okay? And remember, when outliers skew our average, that's why sometimes we might rather look at the median, okay? So outliers affect an average, but not a median. So this problem, remember, standard deviation is the measure of spread away from the center or the average. So this should be a pretty easy problem. If you want a standard deviation of 0, that means everybody got the same score. Okay, now down below, okay, so remember, let's think of people as cups and noodles as points. Okay, we need the average to be 80. So there's a couple different ways I could think of this, right? These people are well below 80, which means that the other two people are going to have to be well above 80. Okay, so I could think of it that way. I could think, well, this person is 12 below 80. So then if I gave 12 to 80, that would be a 92. And then this person is 4 below 80. So let me give 4 to the other person, right, to counterbalance. And I could get these two scores. Okay, and then we had to give 2 other possible scores to be 80, which I could just say, well, then if this person gets an extra point, then this person loses a point. Okay, or another way to think of this is if these cups have to average out to 80, I need to have a total number of points. Right? The total points earned by all 4 has to be 4 times 80, which is 320. Okay, so then I can look at what I already have and say, okay, well, 320, if I were to subtract 68 and 76, right, I need 176 more points. Okay, which if I divide that in half, since it's an even number, my other 2 people could both have an 88. Okay, so the nice thing about this problem, often we say a problem is a good problem when there's a variety of answers. Okay, as you can see, both of the answers I gave here added to 176. So I could do anything as long as it adds to 176. Now, of course, scores can't go over 100, but I could say, well, maybe one person got 100 and the other person got a 76. Okay, and I could do any combination. I could say, well, maybe somebody got a 95. Now, what would the other person have to have had? Well, let's do 176 minus 95. They would have needed an 81. Okay, but if this were a test question, the way I would test the answer is I would take whatever numbers you gave me and just make sure that they added up to 176. Okay, and that's how I would write my answer key, right? Do the other 2 scores add up to 176? Now, number 5, probably number 5, there's not really a formula or anything you'd be using here. Probably you're going to need to use a little bit of guess and check. Okay, and so her middle score is 90. We need to have an average of 92, which means this test has got to be given 2 more points. All right, so and we also know then the difference between these 2 has to be 6. Okay, so if I tried guessing, like I realized if I put a 92 here, then that would give an extra 2 points, but then I need something 6 points lower. Okay, so and the average has to be a 90. Okay, so I need something higher here than a 92. So the first thing I tried to put here was a 94, um, which I quickly realized, okay, so if I put a 94 here and I've got to be 6 points lower, then that's got to be an 88. Okay, so this person can give away 2, or no, I'm sorry, they can give away 4, but then this guy needs, um, wait, I circled the wrong thing. I'm sorry. This is what I want to be focusing on, the 92. Okay. So this person, yes, I was thinking the average was 90. I'm sorry. The median is 90. So this person can give away 2 points. And but this guy would then need, so this would balance out okay, except the problem is this guy would need 4 points. Okay, so that's not going to work. So, then I just try something else. Well, what if I had a 95 here? Okay, then this person could give away 3, but I need 2 more here to get up to a 92. And if I had to be 6 lower to have a range of 6, that would be an 89, but this guy would need 3 points. Okay, so I can tell that I'm getting closer. Okay, so try 96. You might feel like, oh, well, that I need to jump up by 2, but remember, if this goes up 1, this gets to go up 1 too. Okay, because the range is 6. So now if I look at this, both of these guys need a 2. Right? They both need 2 more points. And this guy with a 96, they get to give away 4. And that's when if these numbers, what I get to give away and what I need, if they add up to 0, then I know I've got my average. Okay, so this would be the correct scores. Okay, so that just took a little bit of trial and error.